Okay, these are the 8.1 notes with volume. The only problem is I'm running this from my computer and not the smartboard, so writing really isn't going to be an option. If you want to see the writing part of this, watch the other video. So here's the multiplying part. When you're multiplying powers, you actually end up adding the exponents. Let me show you what that looks like. 5 to the 6th power means 5 times 5 times 5 times 5, 6 times. That's 1, 2, 3, 4, 5, 6. But then we also, and the time sign is really hard for me to type, so deal. Then we multiply that by 5 times 5 times 5. Well, this is all actually multiplication, right? Times, times, I can come in here and do all of this. Well, there's 5 to the 6th power times 5 to the 3rd power. Look at what you end up having. You end up having 5 9 times. That's where we get it. You're repeatedly multiplying. That's what exponents are. So 5 to the 6th power means 6 5s. Times 5 to the 3rd power means 3 more 5s. Now the key to this is that they have to have the same, that's not where I wanted that. They have to have the same base. You gotta have the same base. If I take 5 to the 6th power and multiply it by 3, that's not the same base. So take a look at these. 2 to the 2nd power times 2 to the 3rd power literally means 2 to the 2 plus 3 power. Your answer should be 2 to the 5th power. And make sure your exponents look like little bitty exponents, but you get the hint, right? Now, if you're multiplying several terms, it's still the same thing. This is 9W's times 2 more W's times 7 more W's. That is literally 9 plus 2 plus 7 as an exponent, which would give us 18. Small little exponent. So that really is that easy. Now, letter C, the 4, doesn't have an exponent with it. Any number that doesn't have an exponent, it really does have an exponent, and its exponent is 1, because technically there's 1 4 there. This is 4 times 4 times 4, 4 times 4 times 4 times 4, and then we take that times 1 more 4. Well, look at how many 4s we have. 4 plus 1. We had 4 4s, and then we add 1 more 4. You got it. That is 4 to the 5th power. Now watch out for negative numbers. Negative 6, even though it doesn't have an exponent here, we know that its exponent is actually 1. And times negative 6 to the 6th power. Now notice that the negative is in parentheses, but it's the same base. Notice that the answer has it in parentheses still. This is literally negative 6 to the 7th power. Now be very careful when you're talking about negative 6 and taking that to a power. Hold on, because I need my tools here. When you're taking negative 6 to a power, this answer is very, very different. Oh, not where I wanted to go. Sorry, folks. That answer is very, very different. Get me out of that. Is very different than this answer. If the negative is outside the parentheses, the exponent doesn't have to touch it. The exponent does not like touching or sharing. Doesn't like it at all. If it doesn't have to, it's not going to share. But the exponent in this problem has negative 6 to the 2nd power. That is literally negative 6 times negative 6. This one is only squaring the 6 and has nothing to do with the negative. It's basically like negative 1 times all of this. If the negative isn't in the parentheses, it's not included. So this answer would be negative 36, where this answer would be positive 36. Be very careful. Exponents do not like to share. Now, if you're taking a power to a power, you actually multiply the exponents, because this is 3 to the 4th power, and we're taking that expression to the 2nd power. That means 3 to the 4th power twice. Well, when you take 3 to the 4th power times 3 to the 4th power, there's 2 of them, right? We add those exponents and get 8. Or how else can you use 4 and 2 to get 8? By multiplying them. A power to a power, multiply those exponents. So this literally is, oops, sorry, I'm over at the examples. 5 to the second power and that to the third power is literally 3 5 squareds. So 5 squared times 5 squared times 5 squared. That is 5 to the sixth power. N to the seventh power to the second power, literally n to the 14th power. Now notice C, you have a negative number in parentheses. Look at your answer. The negative number is in parentheses. And then we're just taking that power expression to the power of 3. Multiply those numbers. Now D is a subtraction problem. Now remember your order of operations. Parentheses, exponents, multiplication, division, addition, and subtraction. Now we're up here in the land of exponents. This is where we are. This is a subtraction problem. All the way down here, all the way down there. Now we can't skip we can't skip order of operations. You can go from one level to the next level, but you can't skip from one level all the way down. So my exponent, I'm taking z minus 4 to the second power and that whole thing to the fifth power. Notice they kept z minus 4, because whatever that is, I'm taking it to the second power. And then to the fifth power, my answer is that subtraction problem to the 10th power. Now be careful, z minus 4 and then that number to the 10th power is very different than the answer we have here, because look at who the exponent is touching. It's only touching the 4. We want it to touch the subtraction problem, so that is not your right answer. Delete, go away. Okay, now if you're taking a subtraction problem to a power, so a times b to a power, this is literally, I know the number problems aren't your best example, but if this were a, I'm in caps, a times b to the fifth power. Let's do that to the fifth power. That literally means, ooh, what am I doing? Get rid of it. Literally means a times b times a times b times a times b, there's 3 times, times a times b, there's 4 times, times a times b. I just did a times b 5 times. A times b, a times b, a times b, a times b. Well, hey, look, there seems to be 5 a's. 5, not 2, sorry. There looks to be 5 a's. That's a to the fifth power. A times a times a times a times a. You can't see me counting on my finger, but that's what I'm doing. And then there's 5 b's. So hey, b to the fifth power. What do you notice? That exponent of 5 got basically distributed to everything. Now we're going to laugh at me while I try to write in pen. That 5 basically just got distributed to the A and to the B. So you distribute it to everything. Now, I skipped example at letter A because it's weird. It literally is 4 to the 7th power. Yes, I'm writing with my mouse. Times 16 to the 7th power. Distribute that power to everything. Here, you've got -3 in parentheses, so it counts, times r times s. That's what that means when you smash it all together. That means we're going to take -3 to the second power, r, not 4, r to the second power, and s to the second power. Now, you can simplify some of this. If you've got numbers with exponents, evaluate, look where it says, evaluate the numerical power. Only do that if you have numbers and variables around. Well, think about it. This is -3 times -3. What would that give you? What is that value? Negative times a negative, it would give you positive 9 r squared. Oh, typing. R squared. And then s squared. That would be your final answer. A positive 9 r squared s squared. Look at letter C. The only difference is the negative's on the outside. Notice the negative stays on the outside. This is like -1 times all of this, because that squared doesn't go to it. So this is 3 times r times s. And so we're going to get the 3 squared. We're going to get the r squared. And we're going to get the s squared. Look at me go. Now this time, the negative is on the outside. So this answer is negative 9 r squared. I figured out what I was doing wrong. S squared. This one's negative because the negative was on the outside of the parentheses. So let's try it all together. Now I'm going to pause this and answer all of these. You pause this and try to beat me. All right, hold on. All right, are these the answers that you got? Woohoo! Notice the final answers at the bottom. I simplified the numbers when I saw them with a variable. Now you're going to have to use kind of all the properties together. So here you've got x squared times this whole expression to the third power. Well, remember your order of operations. MD, not MN. There you go. Well, we got to do the parentheses first. The only problem is there's nothing to solve in the parentheses. So let's move to the exponents. Now, x squared is an exponent, but here this expression is to a power. Let's take care of that first. See if I can write this faster. My pen. Let's go right. So x squared I can't do anything with. Don't judge the handwriting. But I can take my 3 to the third power. My x is already to the third power. My x to the third power, and I'm taking that to the third power. So that actually means x to the 9th power. And then y to the third power. Now, I have an x squared here and an x to the 9th here. I can combine those. 3 to the third. X is now to the 11th, and y to the third. I don't have anything to simplify that way. Now I have a number with my variable, so let's solve that. 3 times 3 times 3, 27. X to the 11th. Y to the third, and no joke, that's your answer right there. That is your final answer. 27, x to the 11th power, y to the third power. So take a second, pause this, see if you can answer these. All right, how'd you do? 2 to the 4th is how I got 16, and if x is to the 5th and then also to the 4th, I multiply those powers. 3 to the 4th is 81. Y to the 3rd to the 4th power is y to the 12th, and then times y to the 5th, add those exponents. Magnitudes, power of 10 are not on your test, so I'm not going to worry about them. So here are the verbalized notes.